Okay, then I'll continue with the next materials. It's still regarding the properties of the fluids that quite important when we discuss about fluid mechanics, but this one is called vapor pressure. So vapor pressure is a concept that's actually liquid in certain condition. It means in certain temperature and also pressure, it will have it will change the phase into vapor or gas state or gas phase. This is what you call saturation condition. So in maybe you have learned about the phase diagram in thermodynamics. So when you correlate pressure and temperature, the diagram will looks like this. Yeah, it's similar like this, or actually I'll show you. Yeah, a bit like this, right? Sorry for my this one. So this will be solid, this will be gas, and this will be liquid. Sorry, this one not gas, but vapor. And this will be this called triple point. This one is triple point. And this one is critical line. When you approach to the this one, it becomes the gas, and this in this area it will be supercritic. Ya, jadi ini adalah daerah diagram fasa, phase diagram for single substance untuk satu zat murni. So at certain pressure and temperature, the phase of the component or one substance will be solid or vapor or liquid. But further from the solid liquid vapor area, the phase will be gas, sometimes it's gas, and in a certain temperature and pressure, it will be supercritic. Okay. Do you know the difference between gas and vapor? Anyone can explain a bit about what is the difference between gas and vapor? The phase is the same, gas, but some substance are called gas and some substance called vapor.
Can I answer, sir?
Yes.
If I'm not wrong, yeah.
Yes, you are correct.
So before even reaching the boiling point, some liquids can already evaporate. That's called vapor. But if it reaches more than its boiling point, it might be called gas. Is that true, sir?
Well, it's not exactly true, but it's not correct either. So you see this line. This called boiling line. So it will represent the condition or the temperature at certain pressure where the liquid will start to form vapor. So in order to form vapor, we talk or we discuss about one single substance. So for one single substance, it will have one point which called boiling point. Boiling points mean the temperature at certain pressure where the substance will change will change the phase from liquid into vapor. Ya, jadi untuk satu komponen atau satu komponen single ya, itu ada yang namanya titik didih, di mana titik didih itu adalah temperatur pada tekanan tertentu di mana substance yang awalnya itu adalah cair itu akan berubah menjadi vapor. So when the liquid starts change the form at the boiling point means any point in the boiling line, then the liquid will form vapor. It means that if we reverse the condition, I mean you can decrease the temperature or increase the pressure a bit, then the vapor will change back into liquid. So the definition of vapor is a gas that can be relatively easily, means you change the temperature or you change the pressure and it will comes back into liquid. Jadi uap, vapor itu adalah gas yang kalau Anda ubah sedikit temperaturnya atau tekanannya, temperaturnya diturunkan. It means if you want to change from vapor to liquid, you can go up like this or like this, right? It means you can decrease the temperature or increase the pressure. It will change into liquid. Or if the state, the initial state is liquid, then you change a bit the temperature or the pressure, you increase the temperature, or you decrease the pressure, then it will change into vapor. How about gas? Gas is not that easy to be changed into liquid. So gas is a state, the state of the substance at certain temperature and pressure. So it means here, where it cannot be easily changed into liquid. Can you understand the explanation? Jadi, kalau gas itu tidak mudah untuk berubah menjadi cair. Tapi kalau uap, itu berarti kondisi di mana fasanya sudah gas, tapi dia mudah untuk menjadi cair. Cara menjadi cairnya bagaimana? Temperaturnya diturunkan, atau tekanannya dinaikkan, atau dua-duanya. Sama juga, cairan itu akan mudah menjadi uap, kalau tekanannya diturunkan atau temperaturnya dinaikkan. That's the differences between liquid and vapor. Okay.
Sir?
Yes?
How about the superoritic and the critical line, sir? What's that, sir?
The supercritical is false here, right? It means at very high pressure or very high temperature, the phase of the substance will be supercritic. Supercritics means it's neither liquid, it's neither vapor, or it's neither gas. The condition or the phase is supercritical. It's like
so what phase is that, sir?
Kasat mata itu apa? If we actually we cannot see the phase, like so we can consider it like a gas, but the gas is a very specific. It's even more specific properties. The properties is the very high pressure and very high temperature. So we call it supercritic. Kalau Anda lihat secara penampakan tidak akan ada bedanya kan ya, uap, gas, dan superkritik. Kalau cairan atau padatan kan kelihatan ya, oh ini cair, ini padat. Kalau sudah uap, gas, itu kan nggak bisa dilihat. Jadi ya secara penampakan ya mirip gas, mirip uap. But the phase we call it supercritic. Because it has a very, very high pressure and very, very high temperature.
When it exceeds the critical line, yes, sir?
Yes, when it exceeds the critical line.
Okay.
Later, when you study the thermodynamics, and later, I think next year, when you study like diffusional separation process, then you will learn more about the supercritical state of the substance. Okay, now we go back to the boiling line. So the boiling line is this the condition where the liquid will change into vapor, and also the vapor will change into liquid. Okay, this is called the saturation pressure or saturation pressure or saturation temperature. Atau titik jenuh atau daerah jenuh. So at boiling line or boiling point, we can call that substance is already reaching the saturation condition. After reaching the saturation condition, the change of the phase of the substance will change. Okay, when the liquid, for example, change the phase into vapor, so some of the molecules change from previously in the liquid form, and then it changed into in the vapor form. What happened in the saturation condition? There will be some balance between vapor that change to the vapor or vapor that change into the liquid. Ya, jadi ada kesetimbangan, or there will be equilibrium between the liquid molecule and the vapor molecule. And we can, this vapor pressure of one single substance, or we can call it vapor pressure of pure substance, is the pressure that exerted by the vapor molecule when the system is in equilibrium. Jadi tekanan uap itu adalah tekanan yang diberikan oleh si uap. Namanya juga tekanan uap ya. Tekanan yang diberikan oleh si uap. Kapan uap itu memberi tekanan? Ketika dia berada dalam kesetimbangan dengan cairan. Kapan itu terjadinya? Terjadinya pada kondisi saturation. Okay. So, vapor pressure of a pure substance is the pressure that exerted by vapor molecule when the system is in equilibrium with its liquid molecule at certain temperature. It happened during the saturation condition. This one is the saturation condition. Oke, ada pertanyaan dulu? Can I continue?
Sir, so it only occurs in specific temperature and pressure, sir?
Right. So the equilibrium will happen at certain temperature and pressure. So it means when the temperature is changed, like for example, the first temperature here. So the saturation condition, it means the saturation pressure will be at this point. But if the temperature is at this point, then the saturation pressure will be this point.
So, sir, the boiling line is actually the saturation condition, sir?
Yes, the boiling line is the saturation condition.
Oh, okay.
Yeah.
Thank you, sir.
Okay, any other question? Okay, I'll continue. Okay, how to calculate the vapor pressure? Actually, there's some equation that you can use. So from the previous explanation, vapor pressure of one substance is the saturation pressure of pure substance. Ya, jadi tekanan uap dari suatu zat itu sebetulnya ya sama. Tekanan saturasi dari zat tersebut. Tekanan saturasi itu apa? What is the saturation pressure? Is the pressure when the substance reach saturated condition or in the boiling line or boiling point. Boiling point is pressure and temperature point. Okay, so the vapor pressure will be equal to the saturation pressure of pure substance. Then to calculate the saturation pressure, you can use what you call Antoine equation. Have you learned this in thermodynamics? Kuliah termodinamikanya udah sampai sini belum?
Belum, sir.
Oke, then jadi diterima dulu saja konsepnya. So the saturation pressure of pure substance you can calculate using Antoine equation. Antoine equation correlate pressure and temperature. Jadi pada temperatur berapa tekanan uapnya berapa, Anda bisa hitung dengan Antoine equation. So you can calculate the vapor pressure or saturation pressure by using this Antoine equation. It correlates between pressure and temperature. It will be three constants. You can call it A, B, and C. So it will be different from 4 different substance. Ya, jadi ada konstanta A, B, and C itu adalah konstanta, constants, and it will depends on the substance. For example, for water, it will have certain value of A, B, and C. And for like ethanol or maybe another oil or hydrocarbons or others compounds, it has different A, B, and C value. Where you can get this A, B, C value, then you can use you can get the value from handbook, for example. And it will be different if you are using different units of temperature. For example, if you see from some handbooks, temperature will be in degree C. If you have A, B, and C for water, for example, then if you are using temperature in Kelvin unit, the A, B, C value, even though it's the same water, it will be different. Ya, jadi hati-hati. Please be careful when you we are not dealing much with the vapor pressure in this class in fluid mechanics, but later in thermodynamics, then you have to pay attention that the ABC will be depends on the unit of the temperature as well. Jadi kalau Anda menggunakan T-nya itu derajat Celcius, dengan Anda menggunakan T-nya itu Kelvin, itu ABC-nya beda. Okay? Then, this is for pure substance. So at certain temperature, one pure substance will have one value of saturation pressure. How if you have a mixture of substance? For example, air, you have 80% of nitrogen and 20% of oxygen, right? So the saturation pressure of nitrogen and oxygen, you can calculate at, for example, at 25 degrees C, then you can calculate nitrogen and you can calculate oxygen using this Antoine equation. One for oxygen and one for nitrogen. Just put the value of the temperature and then get the constant A, B, and C, then you get the value of PV, right? PV for nitrogen and PV for oxygen. Then, if you want to calculate the vapor pressure of mixture of 80% of nitrogen and 20% of oxygen, for example, in the air, then you just calculate by PV of mixture is this one. This is the mole fraction of the component, the 80% and 20%. So this one is 8 PV nitrogen plus 0.2 times PV of oxygen. Coret-coretnya kelihatan ya?
Kelihatan, sir.
Okay.
So the PV, you use the Antoine equation, right, sir?
Yes, the Antoine equation is PV for one single substance. For example, just for nitrogen or for oxygen. After you get the value of the PV for each component, then if you want to calculate the pressure of air is a mixture, right? Air is not a single substance. Then you just calculate by using the composition of each of the component times the saturation pressure of each component. Ini yang disebut dengan Raoult's law. That's what we call Raoult's law. It's correlate the vapor pressure of mixture by summation, penjumlahan, from each saturation pressure of pure substance times the composition or times the mole fraction. X will be the mole fraction of the substance. Ini dengan asumsi 80%, 20% ini adalah mole, fraksi mol ya. With the assumption this 80 and 20% is the mole fraction of nitrogen and oxygen respectively. Okay, I'll continue. Okay, related to the vapor pressure, another concept is compressibility. Another properties of the fluid is called compressibility. So compressibility is a parameter that quantify how easy or how difficult some fluids, either it's gas or liquid, how easy it can be compressed. Compress means increasing the pressure. Yeah. Compress means increasing the pressure. So compressibility is a measure of change in the volume of fluid as a response to a pressure change. If you compress the fluid, you increase the pressure of the fluid, the volume of the fluid will increase or reduce. If you compress the fluid. Kalau Anda memberikan tekanan pada suatu fluida, maka volumenya naik atau turun?
Turun, sir.
Yeah, if you increase the pressure, the volume will be decreased. For gas, if you increase the pressure, the decrease in volume is very significant. Untuk gas, kalau Anda menaikkan tekanannya, maka penurunan volumenya akan signifikan. For gas, it's called compressible fluid, or it has high pressure, high compressibility, because for gas, if you increase the pressure, the volume will decrease significantly. However, for the liquid, if you increase the pressure, the volume will not really decrease. Or we can say for liquid, if you increase the pressure, the volume, we can assume it remains constant. So liquid we call incompressible fluid, or it has low compressibility. It backs to the PT diagram, right? This is solid, liquid, vapor, and gas. So when you increase the pressure, right? Then this is vapor, gas, liquid, and solid. So when you increase the gas, the volume will reduce, and at some condition, gas or vapor, then gas in this context is including vapor as well. So for certain substance, when initial state is gas or vapor, when you increase the pressure, it will change into liquid. It means the reducement of the volume is very, very high. The gas will change the phase into liquid. Ya, makanya kalau gas atau vapor atau uap itu ketika karena kan di sini ya, karena because in gas or vapor, the distance between molecules is very high. Jarak antar molekulnya sangat jauh. The distance between molecules is very, very high. So if you increase the pressure, it can lower the distance between molecules. So the volume will reduce. However, for liquid, because the distance between molecules is already close to each other, when you increase the pressure, then the reduction in or the decrease in volume is not significant. Any question first?
Sir, I have a question, sir.
Hmm?
So if liquid, no matter how hard you compress, there is no way it will turn to solid, right?
No, because it's here, right? The phase diagram is like this. So if you increase the pressure, it will change. It will not change into solid. But if you decrease the temperature, at some point it might change into solid.
Okay, sir.
Okay. Any other question? Okay, then I'll continue to the next slide. Sorry, this one is just correlating the equation for gas. So if we talk about compressibility, it means it's for gas because liquid is not compressible enough or it even called incompressible. So if we talk gas compressibility at constant temperature, then it means you just change the volume of the gas. You do not, you just increase the pressure, you just reducing the volume. Isothermal means all happens in the constant temperature. Later we will discuss it in the PT diagram again. So the device to use the device that is used to increase the temperature of the gas significantly called compressor. Ya, jadi nama alatnya namanya kompresor. Kompresor itu adalah alat untuk menaikkan tekanan gas tapi yang sangat-sangat signifikan. For lower or even very slight increase in pressure for the gas, we call it a blower or fan. Ya, jadi nanti later in the next a few chapters in this fluid mechanics, there will be two types of alat penggerak fluida, fluid movement machine, especially for the gas. First is blower or fan. The second one is compressor. So blower is merely to increase just the speed or the velocity, but the change in pressure is not significant. But the compressor is to increase the pressure significantly. Ya, jadi ada dua alat nanti di pembahasan nanti tapi ya. Alat penggerak fluida gas itu ada dua. Ada yang namanya blower atau kipas. Jadi itu hanya untuk menaikkan kecepatannya saja, tapi tekanannya relatif konstan. Sehingga ya nanti efeknya ke densitas ya. Karena kemarin kita sudah belajar, previously we have learned about the density. Density is changed if we change the pressure and temperature, especially for the gas. And in blower or fan, the density of the gas can still be considered constant. But if you use compressor, it means the pressure of the gas is changed significantly, and then the density of the gas is also changed significantly. Okay, there's some equation because you already know ideal gas, right? Please don't forget this equation. It means you can use this one, right? The ideal gas is P pressure times volume equals moles times constant time temperature. It means how you increase the pressure or how you increase the temperature and how the volume is changed, the moles of the substance will be constant, right? Ya, bagaimanapun Anda menaikkan tekanan atau menaikkan temperatur, menurunkan tekanan, menurunkan temperatur, kemudian volumenya berubah, naik turun, zatnya kan sama ya. The substance inside the system is still the same, right? You do not add additional substance or you do not take the substance out from the system. It means the number of or the mass of the substance, the moles of the substance is constant. Then this equation, we call it Boyle-Gay-Lussac's law. The change in pressure, volume, and temperature in every condition will be constant. P times V over T will be constant. If you do the compression, this is compression happen at different temperature. So the first temperature will be different at the second temperature because some effect of the compression might be increasing or decreasing of temperature. But if you do the compression in constant temperature, or you call it isothermal compression, then you can use this equation. Okay, same with Raoult's law. Then the pressure of gas mixture, then basically it's just the summation of the partial pressure. So you maybe you already heard about partial pressure and total pressure. For example, air, again, you have this one is 0.2 atm. For example, PO2 is 0.8 atm. Then the total will be 1 atm, for example. So this one, 0.2 is the partial pressure of nitrogen, and 0.8 is, kebalik ya ini ya. The 0.8 is the partial pressure of nitrogen, and 0.2 is the partial pressure of oxygen. And the total pressure will be 1 atm. And partial pressure will be 0.8 atm divided by 1 atm. Oh, sorry, not partial pressure. This one. The fraction of the gas is the ratio between the partial pressure divided by the total pressure. Ya, jadi fraksi gas Y itu adalah tekanan parsial dari zat tadi dibagi dengan tekanan total dari sistem. Okay, any question first? Still awake, right?
Yes, sir.
Okay. Yeah, this is the concept of partial pressure and total pressure. This one is partial pressure, and this one is total pressure. And Y is equals partial pressure of the component divided by the total pressure of the system. Okay, before this one, I want to show this one. This is the PT diagram. And the function of knowing the vapor pressure and then knowing the compressibility of the gas is to see or to know how we can condense the gas. Condense means change the phase from gas to liquid. So if you want to condense the gas will be in position 1, and liquid will be in this position, right? Either 3, 4, or 6, 3, 4, or 6. At point 3, point 4, or point 6, the gas will start changing into liquid. So how to condense the gas? You can do the compression. Compression means from step 1 into 3. Compressions mean the T is constant, and then you increase the pressure. The other method will be what we call cooling. Cooling is from step 1 into, from point 1 into point 6. So the pressure is constant, but you decrease the temperature. Or you can do the simultaneous compression and cooling from point 1 to 4, this one. So you increase the pressure and decrease the temperature. Or you do it step by step, like compression first, followed by cooling, or cooling first, followed by compression. So this is the alternative ways or methods you can change the gas into the liquid. Why we want to change the gas into liquid? Because we want to decrease the volume. Why we want to decrease the volume? So it's easier for us to transport the gas. Because transportation of gas, the molecules is very large apart, right? The distance between molecules is very large apart. So if you want to transfer the same amount, the same mass of substance, it will have less volume if the phase of the substance is in liquid form. Ya. Jadi kalau Anda mau mentransportasikan suatu zat, jumlah zatnya itu sama, maka transportasinya, volumenya itu akan lebih kecil kalau bentuk zatnya adalah cair. So by using liquid form, we can transport substance in less or very significantly lesser volume. Lower volume means easier handling, right? Jadi kalau Anda menghandle volume yang lebih kecil, itu kan lebih gampang. Okay?
Sir, I have a question, sir.
Yes?
If, for example, like in the real world, yes, sir, if you apply pressure, wouldn't the temperature also increase, sir? So is it actually hard to balance that, sir?
Yeah, normally if you increase the pressure, the just do, for normal operation, when you increase the pressure without any additional measurement or before any additional works, then the temperature of the system will also increase. That's the actual condition. Itu kondisi, not actual, but it means kondisi apa ya istilahnya ya? Ya, kalau Anda menaikkan tekanan begitu saja ya, tanpa ada perlakuan-perlakuan tambahan khusus, maka temperaturnya akan naik. So it means if you want to keep the temperature at constant temperature, then you have to do additional works, additional activities must be done to keep the temperature in constant temperature. It means you add some cooling agent in the system, or you reduce the heat that produced by the compression, for example. So for some compressor, it will have certain mechanism to keep the temperature if constant if you want to do the isothermal compression.
Okay, sir. Thank you.
Okay, so related to the compression and condensation, yeah, some fluid is easy to condense, and some fluid is very difficult to condense. So like a fluid that easily to condense, usually it's difficult to evaporate. Evaporate means change the phase from liquid to vapor. Vice versa, if the fluids is difficult to condense, usually it's very easy to evaporate. It will be depending on the substance. It means it will be depending on the pressure temperature curve for each substance. And for this phenomena, maybe later you will find the term condensable fluid. It is the fluid that really easy to condense at normal pressure and temperature. Jadi fluida condensable itu adalah gas yang gampang untuk berubah menjadi cair, gampang terkondensasi pada kondisi tekanan dan temperatur normal. Okay. Related to the compressibility, we use the parameter we call compressibility factor. So it's actually the ratio, the compressibility factor, this one, is actually the ratio of the specific volume. Do you still remember the specific volume? What is the definition of the specific volume?
In 1 mole, sir?
What is the unit of specific volume? Volume over volume spesifik. Satuannya
Over mole, benar nggak sih, sir?
Yeah, you can use volume per mole or volume per mass.
Per mass ya?
Yes.
Kilogram, right, sir?
Yes. Jadi satuannya bisa liter atau meter kubik per mol atau meter kubik per kilogram. Same. So, not the same. Can be either of these two units or volume per mass. This is the specific volume. So, the compressibility factor is defined as the ratio of the specific volume of non-ideal gas compared to specific volume of ideal gas at the same temperature and pressure. Ya, jadi faktor kompresibilitas itu sebetulnya adalah perbandingan atau rasio dari volume spesifik kalau pada P dan T tertentu gas ideal itu spesifik volumenya berapa, kalau gas nyata spesifik volumenya berapa, rasionya itu berapa, nah itu yang disebut dengan compressibility factor. Specific volume is actually V over N, right? This one is the specific volume. Okay, so certain gas will have certain value of compressibility factor. It will be depends on temperature and pressure. How you can get the compressibility factor for certain types of gas? Then you can again find in the internet, you can find in the handbook, etc. This is the example of air. Air is a gas. Then the compressibility factor. So it means if Z equals 1, it means the gas will be ideal, right? So this one will be the ideal gas. Any question? Is it too fast or is it too slow?
It's fine, sir.
Or just
Okay.
Sir, for the specific volume itu kayak udah ketetapan gitu ya?
Maksudnya gimana?
Jadi kayak betulan tadi ada tabel tuh. Itu kayak
Okay, this one, yeah, it will depends on the where you use specific volume. Actually, if you see, N over V is what? Moles over volume. It will be mass over this one divided by volume, right? And this one will be density, right?
yes.
Yeah. Well, we use specific volume instead of density because if we change the pressure or we change the temperature, the volume will change. Ya, jadi kalau kita mengubah tekanan dan temperatur itu, ini kan kita ngomongin gas ya. Gas is very susceptible to change of gas density is very depending on change in pressure and temperature. So we are using volume over mass to compensate the change in volume. Jadi di sini volume spesifik digunakan sebagai satuan karena ini menyatakan berapa volume dari sekian massa atau sekian jumlah suatu gas pada tekanan dan temperatur tertentu. So the value of the specific volume or the value of the density will be given at certain temperature and pressure, right? Is that answering your question? Yeah. So the value of
Yes,
specific volume, it's relatively constant throughout the change of pressure and temperature. Compared
yes,
to,
I understand.
okay,
Thank you, sir.
ada pertanyaan lagi? Tidak ada. Jadi untuk materi yang ini materinya sudah habis untuk slide ini. Apakah ada yang perlu diulang penjelasannya terkait materi-materi yang kemarin terkait properties of the fluids? Dari soal-soal latihan sudah cukup jelas ya from the exercise. Do you need further explanation?
So far it's okay sih, sir.
Okay, then when our next class? Thursday, right? Okay, then on Thursday we will continue our discussion about fluid static. Okay, thank you and good afternoon.